Game hacking 101. I'm gonna try to explain this as simple as I can. Um, we will be going over memory editing. We won't be doing hex editing, that type of stuff. So, what is memory editing essentially? Memory editing is essentially making changes to the game while it is running. We can do this by editing the certain address. And memory editing is not the best type of hacking or cheating, however you want to call it. There is a much better way, which is called assembly hacking. But though I'm not really going to go over assembly hacking, only memory editing. So for everything that you will need, you'll need cheat engine, um, or Sigil. There's something else that was made by Guiding Hacking called like Sigil. It's a pretty good one as well. You'll need any IDE slash code editor, and then last but not least, a game you want to tamper with. So we need to first understand the basic Windows 32 API functions. So the main ones that we're going to use today is write process memory and open process. So if you take a look over here at the write process memory syntax, you can see the first object we have to pass through is the handle process. The second one is the base address that we are searching for. The third one is the buffer, aka like what we want to replace it with. And then the size is the size of the buffer, I'm pretty sure. And then number of bytes written. This isn't so important to us. For us, we are going to put this as none because there's no use for us to use it. And then for open process, our first object we have to pass through is our desired access. So I'll go over that once we get to that. Then the inherent handle, which will just be our, like, if you want to like copy over your work to that. So you always want to put false for that. And then the process ID is just going to be the process ID of the game you are trying to hack. So hopefully you're ready for the live demo. I'll be going over what I'm doing while I'm making the actual code to hack the game. I'll be making a little game because I don't want to hack some other person's game. I don't really condone that. So let's get started, shall we? Oh, don't mind that. Alright, so let's open up Visual Studio real quick. So in our case, we're going to be using the IDE to make the game real quick. Create a new project. We're going to just make a little simple game. Here we are. So we're gonna just make a simple tiny little game first. So we're just gonna do int health is equal to 100, and then we're gonna do wow. We'll do here. We need to involve reds real quick. We'll do while thread sleep 1000. Do console.write line health .toString. And we'll do health is oops, minus equal 1. So what's wrong with this real quick? Oh, okay. Yeah, I guess we do need a put watcher here. We can just put thread.c down here. I've been messing with other programming, I'm not programming, scripting languages recently, and I'm so used to doing that right now. Okay, so I'll go over this real quick. It's not really too important, but you should be able to tell that we have an integer that's health and it's equal to 100, and we're making a loop. This is the while true part, and we're doing everything inside the two brackets right here. So these 3 lines. And each single loop, we are decreasing the health by 1, and then we're writing to the console the health, and then we're waiting 3 seconds, since 3000 milliseconds is 3 seconds. And then it'll start the loop over again. So let's go ahead and run this real quick, just to make sure everything works properly. Don't mind that. Continue. 99, 98, 97. Okay, so it is working. So now that we have that done, we'll just go ahead and copy that real quick and bring it to our desktop. And we won't, well, you may need the IDE, but I don't. So I'll move that right there. And the programming language that I'm actually going to use, not programming, sorry, scripting language, is going to be Python. I'm actually going to use Python to make this little game cheat. So if I can find it, sorry about that, there it is. I'm opening Visual Studio Code because I just like it as my code editor. Then again, it could be anything. So we're going to open a file, go back out here, create a new file. We'll just name this test.python. Oops, almost forgot to open it. I'll remove that, that's not important, just a little aim. I'll move that right next to it so I know it's that, and I'll delete it later. So the first few things that we're going to have to import are actually going to be, oops, import, oh, hold on. Oh, that's not really important. So we're going to import C types. This will allow us to interact with native C and C++ functions. You will have to install this for pip if you do not have it and you're following along in Python. But you can do this in C++ too, whatever language you want that can natively interact with Windows. Well, Windows API, I guess I should say. Then we're gonna import getUtil. This will allow us to manage the processes and stuff like that. You'll also have to install this if you are doing it in Python. Then we're gonna need Windows 32 connection and Windows 32 process. So those two you'll also need to install. But anyways, oh wait, and time. We need time too. So first things first that we're gonna do is we're gonna make a handle. So handle equals ctypes dot what is it? I think, yep, there it is. C void p. And the reason that we put the handle equal to the C void pointer is because in C++, the handle is actually a void pointer type, I'm pretty sure. So then up here, before I forget, we're actually going to do API is equal to ctypes windows dll dot kernel 32. So the API will be our kernel 32. We'll do op is equal to API.open process. That'll be our open process, and WPM is going to be our write process memory. There we go. And now we'll also need a base address. So we'll just set this to 0 for now. So now that we have our open process memory and write process memory along with our handle and base address, we're going to actually define the main function real quick. And right here, we're gonna turn handle and base address into global, so we're able to access it all. Base address. And now we're gonna get our base address. So to do this, we're going to loop for each process inside of psutil dot, I believe it's process iter, yep. Do if process dot name equals blank, then handle is equal to open process. We'll do, I believe, connection dot process all access. So here's where I said we'll get into this whole part right now. So if you remember, open process has 3 objects to pass through. The first one is the privileges that you want. So we want to have all access to this game, right? We want to be able to read and write to it, all that good stuff. So we're going to do process all access, and then false, as I said earlier, and then we'll do the process PID. And how to actually get that base address inside of Python, we're going to have to, we'll just put models, we'll have to get the, let's see, the process modules. I think that's the actual name for it, but we gotta pass through the handle real quick, and then it'll be the very first thing inside of the array for the modules. So base address is equal to modules, and then the first item. And to do this, we can go ahead and print the base address as a string real quick. And then let's define main as well. But first we need to get the name of our exe, which it should just be testgame.exe. So testgame.exe. It may be a little bit different though. You'll definitely have to check it in Task Manager, because like some things like on the browser it'll run like, the best example I can think of is Roblox. Like you would think it would be Roblox player.exe, but it ends up actually being Roblox player beta. So let's go ahead and open our test game real quick. Let's go ahead and run this. And let's see what happens. Yep, and here's our base address. So now that we have that done, we don't need this open. Actually, we'll leave it open for now. And then right here, we'll create a new function, and this will be edit health. Because in our case, let's say we want to edit health, and this is our health, right? So we're going to do edit health. We're going to have a try and a except here. For our except, we'll just print error occurred while writing in memory. And then for up here, we'll just print wrote to memory. And then down here, we're actually gonna call the edit health. Okay, so now that we have this, let's go ahead and get the address for our health inside of this little game. So this is where Cheat Engine will come in handy. So let's open up Cheat Engine real quick. Then we're gonna want to attach the Cheat Engine to our test game. Where is it? There it is. This is also could be tricky sometimes. For some games, you'll have to make sure because they have like two different instances in the background. You'll have to like end the background instance that isn't doing anything if you want to get it 100% accurate. But our game doesn't have that, so we're lucky on that. We're gonna pause the game while scanning and not do a fast scan, just because we don't want a fast scan. And then we're gonna search up the value. So it would be 57 here in a second. Yep. And then 56. Oops. I may mess that up. Oh, yeah, okay. So as you can see, I should have been quicker right there, but good thing it's right up here. So, as you can see, there are 1, 2, 3, 4, 5 of them going down at the same time. And sometimes you don't really want to mess with the value just because a game could detect that, I'm pretty sure, and kick you. So it's not the safest route. So we're actually gonna look at this. We're gonna look at what is writing to them. So, for example, this one right here, we're pushing EBX. If we like look at it more, you can see that it's just pushing EBX. It's not really decreasing the value, so we don't really care for that one. And we'll just do this until we can find it. This one's moving, pretty sure, yep. This one is not what we want either. That's not what we want. And then this one, I'm pretty sure is what we will want, but we'll just check to double check. Yep, you see if you look at it right here, it's actually decreasing the value. So, okay, we're good. We'll stop that. We'll drag this down here. Actually, we don't even need to drag it down there. We can just copy the selected address. So now that we have the address, let me just open up a notepad. This is address for L. I'll zoom in a little bit for you guys. So, oh, didn't mean to full screen that. So here's another kind of occurrence that we have. So there's something called dynamic memory allocation. And so what this does is it kind of scrambles the addresses. So if we tried to look for 0019F500 by itself, we actually wouldn't be able to just edit it. So we're gonna really quickly write a simple ASLR bypass, which is the dynamic memory allocation. SLR, let's write that above this actually. And then we'll pass for an address that has to be an integer. We'll return our address minus, I'm pretty positive it's 0x. I want to say it's 400,000 for the hex, and then we'll have to plus the base address. So now that we have the ASLR bypass down, let's go ahead and, oh yeah, hold on, we'll do while time dot sleep 2 seconds down here. We'll do edit health. We'll move that out now. We'll do write process memory, and then we're writing to the handle. The address we want to write to will be ASLR, and then the address we have from earlier, well, we'll want to signify that it is a hex address, so we'll do 0x in front of it. And then we want to write the value. So how this will work in Python at least is we're going to want to do C types by reference C types dot, I think it's C integer 8 and then 100, and then we'll have to do the size of it. Size of ctypes dot integer 8, and none. So what this is doing right here is we're opening the handle and we're writing to the address of our health, and we're gonna write 100 to that value by reference of integer 8, 100, and then the size of a integer 8 value, and then the buffer that change stack or whatever it's called at the end. We don't want to mess with that, so we're gonna put none there. Now let me just make sure we have everything. Pretty sure we do. So if I want to try running this real quick, we should see that it'll go back up to 100. Maybe. It did not. Okay. Hold on. Fine. I'll try changing this, but this shouldn't affect it. Time about sleep. 2. Start debugging. Okay, wrote to memory. Oh, as you can see, we actually messed it up. We put it to negative 157, which is not what we're trying to do. So this will happen sometimes. It's just human error. Humans aren't perfect, so let's look. I don't see anything wrong with it at first glance, so I'm gonna run the game one last time. I'm gonna try to run this and see if it does the same thing. Nope, it's not. So I'm assuming that it just got messed up because of the negative integers within the game at that time. But now you can see that it's writing to the memory and it's staying at 100 just fine. So this wouldn't necessarily be considered God mode, as if you took 101 damage or some sort, you would die because you took over 100 health of damage. For God mode type stuff, you would need assembly editing, but this course was just on how to write basic memory editing software. So I hope you guys enjoyed this lesson. Hope you guys learned something new, and that's all I had for you today.